Okay, our practical activity will be on Aram chaos. We will try to perform a geomorphological map. We want to stay very simple. This can be done individually or in group. I think it's quite difficult working remotely to join in group. I mean, we will be in groups, but within the groups, maybe somebody would like to work together. That would be a good idea, but maybe it's practically difficult, but feel free to do whatever you prefer. We will work on a chaotic terrain on Mars. First of all, we have always to be conscious that there is no truth without ground truth. Okay, no absolute truth maybe is the right word. The concept is exemplified by this very nice paper from Tanaka et al. 2007. This one on the top is a geological map of the Earth made by normal field geology means, while these other 4 geological maps are geological maps performed by different persons using techniques of the same area, using techniques which are the same of geological mapping on the planet, and image resolution that it is very similar to the one that we had in those time actually on Mars. As you see, maps sometimes are similar, sometimes are actually the same, sometimes are quite different. So we have to be conscious, especially here where there is this white square here. There are some differences, which means that we have to be always very humble on what we do by remote. We have to be conscious about that. Still, again, geological maps is the basic tool for any kind of scientific reconstruction. So it's important that we do that. Now we are going to introduce the activity. Then Riccardo will briefly tell you something about MAPPI. Then we will move to the Mars room and we will start our project. First of all, we will divide in groups. First of all, we will, the idea is to have a look at the units, try to describe them and to, so to say, I don't know how to express it better, to make the eye of each of the unit you want to map, and then you can start the mapping work. Then we will have lunch. In the afternoon, we'll reconvene in the plenary room with the scientific seminar. So we will move finally to science by Dr. Erika Luzzi on the origin of the chaotic terrains. Then we will come back to the Mars room to map. After the coffee break, we will continue to map. I would like to keep the last hour for some presentation and discussion. We will also see your need and whatever. These are the instructions which I'm deeply indebted. The map, you already have the project, you already know that, you already know all this information, so maybe these are redundant, but okay, the map is equidistant cylindrical. Aram chaos is, the regional context is this one. It's a very interesting area because we are somewhere in between the highland and the lowlands of Mars, where a lot of things, probably the most interesting things on Mars occurred. In more detail, I mean, this is Aram chaos. This is the mapping area. You see here an outflow channel originating from here, also from here. This is the global geological map of Mars. We are here in correspondence of Noachian and late Noachian and Hesperian terrains, very roughly speaking. But we don't want to focus too much on the literature. Also, this is an old map. Okay, 2005 is not so old, but the data sets change a lot since then. So, so we will do a map which will be quite different from this one, actually for two reasons. The first reason is that we have a better imagery data set, so we can be much more detailed than this. The second reason is that they were extensively using hyperspectral data that we will have a look. We will have a couple of CRISM images, but we will not use those images in the unit description because it's impossible. We would have need 15 days, not 1 day, maybe 15, no, but also the amount of data would have been much more. So we need to focus on the simple stuff. Of course, the area is huge, so we divided it in 8 tiles, and you are divided in groups. Each group will have 1 tile, which doesn't mean that you don't have to look at the very beginning at the whole area in order to make an idea of the distribution of the several units. Okay, these are the groups. Again, I think this information is redundant because you know this already, and there were some small changes because some people couldn't make it, some other were included, but I think this is redundant. Okay, scale of work, this is important. This depends on, this is something that, of course, it's always dependent on what you want to do. So what's your science goal? Now we are making an exercise, so we do not have a science goal. And so we decided to stay between some 170K, 150K, or even 1 to 100K is good. This, of course, depends also on your screen. So this is just to give you an idea. Do not worry if you will not be able to finish all of your tile. It's better to do, I mean, well, between brackets, a small portion of it and understand what you're doing. I mean, this is an exercise again. You don't want to be stressed, no? Okay, these are 2 screenshots taken with my screen. So in your case, this might look different. So this is just to give you an idea. But in any case, the scale of work will be the first decision you will make. First, you will have an idea of the units, you will describe the units, and then, okay, in order to map this unit, which kind of scale do I need to use? Now I will introduce you the units, so maybe this, what I told before, maybe it will become, hopefully, it will become more clear. In any case, it will become more clear with the practice. The units here are described randomly because the stratigraphic relation is something that you will reconstruct. Feel free to propose different unit or new approach, different approaches, whatever. This is just an idea. First of all, okay, we have the plateau, which is outside of Aram chaos, and we have the mesas. This is one mesa of the chaotic terrains, which are with these fractures, which in some cases bound them, in some other not. We have, again, the plateau, mesa, knobs, with this other morphology of the chaotic terrains. So we have plateau formation of the chaotic terrains. We have a crater here. I always forget about craters because they are everywhere. Then we have this layer deposits. Of course, you cannot see from this scale that they are layered. This is something I will show you later, but they are light tone. This is something very, very, very quite distinctive. And then we have this cap unit, this darker tone cap unit, which is also present. Knobs, very nice knobs here. the cap unit, you can also see some bedding here of the layer deposits here, also here, and you have also some Aeolian bed forms here that you can see here, or also in this position. Other place, many knobs and some mesas here, layer deposits, the cap unit. Okay, this is there is something wrong with the HRC mosaic, but you have also the CTX images in this area to see what's happening here. Here again, okay, sorry, these are knobs. Mounts is an improper word that I was using. It escaped me. Cap unit with some hints of layered units that you can guess here. Grooves, you see these nice grooves that leads to this, to the beginning of the outflow channel, which come out from arm chaos. Now, I was very fast in the description of this unit. We can have a look when we will be in the single groups more, let's say, without this, with more time, with more calm. But in order to start the description, as I was mentioning you before, we can even not formalize, but select reference areas to describe the units. This is something that in some way helps also to reproduce our observation. Or we make a geological map, but okay, color is whatever. What does that color corresponds to? Okay, I have a description in a reference area. We selected just two. Actually, these two areas do not cover all the units, but just the units where also CRISM observation are available. The reference area A is this one. I draw here a profile. Of course, you will be able to do by yourself later on, just to give you an idea of the scales that we are, the thickness of this relief here, for example. To give you an idea, we have the light tone unit, the cap unit. So how they are done, what are their characteristics. This is a 3D perspective view, again, to try and guess their geometry, their lateral relations or vertical relations. We have light tone terrains. Here we have the cap unit here. I don't want to spoil too much, because otherwise there is no, I mean, you will not enjoy the work later. Then we move at CTX scale, so we can make better observation in these two areas. We have also CTX here, and also high-rise. High-rise, of course, will be useless for mapping, because we will not map at high-rise scale, not even at CTX scale. Our map will be performed at high-rise scales, so the units will need to be mappable with HRC, but still these observations will be at high-rise and CTX scale will be useful for a better description of the units, in this case the layer deposits. Okay, Beatrice, if you want to say something about
yes. So yes, these are the CRISM data that you have in this part. And as Monica said, they do not cover globally the area, so they're just very small areas, but it's interesting anyways, because you can see how the mineralogy correlates with some types of morphology. So you will have three products. The first one is the true color gross product. The other one is the hydrated mineralogy gross product, and the third one is the false color gross product. And we can go to the next slide to see some more details. So as I explained in the presentation before, this is just the three red and green and blue colors combined to see the image as it would be seen by our eyes in the visible part of the spectrum. And then if we go to the next slide, this is something slightly different because it combines three wavelengths in the infrared spectrum, and they are thought to highlight some characteristics about the mineralogy of the area. So if you go to the next slide again, thank you. In general, where here in the false gross product, where you see green colors, it may indicate that we have hydrated material. So for example, clays, carbonates, or certain types of sulfates. And where you see gray or brown colors, you might have basaltic material. Next slide. This is instead the most interesting one, the gross product that shows the hydrated mineralogy. Here in red, you have an index that detects some absorption typical of sulfates, while in green, you have an index that detects the H2O band depth in monohydrated sulfates, and in blue, sorry, you have the 1.9 micron H2O band depth. So next slide. So you can interpret that in this way. So polyhydrated sulfates that have strong 1.9 and 2.4 absorption bands appear magenta. And instead, yellow-green colors might indicate monohydrated sulfates, and blue colors are indicative of other hydrated minerals, so might be clays, silica, carbonate. So in this case, it doesn't seem that they are present. Okay, I think this was the last one.
Thank you. Now I'm blocked, but okay, I'm not blocking anymore. This is the other reference area. And again, you can see, sorry, you can see here the a cross section just to have an idea of the scale of this. But again, this is something that you can do with your project in order to see the scale. Sorry, I cannot control this. And here we see knobs, the layered deposits, the cap unit. And we see also we can observe the stratigraphic relations between this unit. Again, I'm not going to spoil this. Maybe these relations are even better expressed by this 3D perspective view. Okay, I stop here, otherwise I spoil it. Here, the same as before, you can make your description using CTX scale, using high-rise scale, and also using CRISP-based information. Beatrice, interrupt me whenever you want, but I think that here is the same as before, so we don't need to tell so much. Okay, the idea is to take these steps now. First of all, I know I told you already, but it's important to, first of all, have a look at the units across all the study area. At all scales, always remember that at the end, the map will be made using HRC images. So you have to describe the units, understand the units, also because maybe later, I don't know if you will have time also to play a little bit with the interpretation, but the interpretation will be based on the description with all the available data. But remember that you will use HRC in order to do mapping. List the unit, that you are planning to map. At that point, decide your scale of work. Again, what we were suggesting you is just an indication. You have to also try to think, I mean, something that is feasible, make feasible to finish all your tile, even if, again, do not be stressed about that. It's just an exercise. And then enjoy mapping. At the end, I would like to discuss all the results together. So at the end, the last hour or so, we will see. I would like to select 1 or 2 maps of each tile, of course, if you want it. So you can just send a screenshot, even here in Zoom, without doing something particularly complicated, with the tile number and maybe also your name. So I will try to merge them very roughly, just in PowerPoint. So something very quick and dirty, in order to discuss the whole crater. Then later, even after the school, you will be able to upload your vector file. Here, I think you will have somewhere the clickable link with a naming convention that will be this one: Mars, first name, last name, and the tile of your work.